So whenever we talk about increasing and decreasing, so at the bottom of page 3, basically, okay, whenever we talk about increasing and decreasing, it's like you've got a little person that is walking on this road somehow, some way, and then if they are going, basically walking down the hill, then that's where the graph is decreasing. If they're walking up the hill, then the graph is increasing. Now, we're not going to deal with anything, not until you get into pre-calc, whenever you have anything that's going to be a constant, or it's just going to be walking across a straight line. That'll come later. Okay? But whenever we deal with increasing and decreasing, okay, there are a little bit of, hopefully, common sense that if you have anything if you have a high point on a hill or a low point like in a valley, like if I'm on top of the hill there, am I increasing or decreasing? If I'm standing on top of a mountain, what am I doing? Am I? But am I continuing to climb? No. If I hit the lowest point, am I going down or going up? Huh? Like if we look at is there a ball back there? Right there on my desk? Blue one? Okay. Whenever I drop this ball, okay, here, what happens? What happens when it hits the floor? It bounces, right? When it hits the floor, it fell, right? I dropped it out of my hand. It was decreasing. Okay? Then what happened? Okay? I dropped it, boom, it came back up. Then it increased, right? What was it doing when it was right there? Wasn't doing anything, right? Okay? Whoever said it. Okay? It was decreasing, and then what did it do? It hit its basically low point, and then it increased again, right? Okay? So at that one point where basically it changes directions, okay, it's not going to do anything. It's not going to increase or decrease. Okay? So whenever we talk about increasing and decreasing, okay, so if I'm looking at this graph here to the right, and I have this blue line right there, okay, I'm going to say that I'm going to call that 1/2, or negative 1/2, and we'll just call it negative 1/2, negative 1/2. Not sure exactly where it's at, but that's where we're going to say it's at. So whenever we talk about, as we move from left to right, if I have a person on this line, are they increasing or decreasing? They're decreasing, right? So they're decreasing, okay? Whenever we talk about our increasing and decreasing, we're always going to talk about our x values. We're not going to talk about how high it is or how low it is. But my graph is decreasing from negative infinity, okay, boom, and then it gets to this point right here at negative 1/2. Now, is negative 1/2 included as far as it decreasing? Are we decreasing when we hit the floor? No. Are we increasing when we hit the floor? No, we're not doing anything, right? So whenever we decrease, so like in this case, if I'm going all the way to negative 1/2 before it starts to turn around, okay, it's going to go from negative infinity to negative 1/2, and that value's not going to be included. Okay, it's not going to be included. So then, from that value, I go to what happens in this little yellow region right there? It increases. So where does it increase from? From where? From negative 1/2 to positive. We'll just call it positive 1/2. So if we call this 1/2, 1/2. So from negative 1/2 to 1/2, we're climbing the hill, right? Then whenever we get to here, what's going to happen? It's going to fall back off, right? Okay, so it's decreasing again, right? So then if it's decreasing, we'll basically go to our decreasing list right here. What's our next interval? From where? Yeah, from positive 1/2 to positive infinity. Okay? It's that value, okay, and we'll talk about, whenever we get really deep into the chapter, we'll talk about what those two values are, because what have we said? Okay? We said basically you can pick up your pencil and you could draw it without ever stopping, right? Okay? I could keep going off to the left, I could keep going off to the right. Okay? With any sort of interval, you should always start somewhere from negative infinity, and you should always end at positive infinity. Okay? Now, we have values that aren't included. Okay? Whenever we get further into it, whenever we really get to the end of the chapter, we're going to talk about what's called like minimums and maximums. Okay? Your minimums and maximums are like the low point of your valley and your high point of your hill. Okay? But we'll get into that later. Okay? So whenever we deal with any sort of increasing or decreasing values, okay, notice that like this would be to the third power, okay, because it's going to cross 1, 2, 3 places. Okay? Or it has 1, 2, 3 either increasing or decreasing intervals. Okay? The number of intervals you have, the number of times this thing changes directions, is going to most likely be your exponent or your degree. Does that make sense? So, like one that's to the left of it, where I think we kind of looked yesterday. How many different times does it change directions? 4, right? 1, 2, 3, 4. So what would you say that the power of this, or the degree of this polynomial probably is? Probably 4. Okay? It could be 6, but it's most likely 4. Okay? Just by looking at it, because it's going to change direction, it's going to decrease here, it's going to increase a little bit, decrease again, and then increase for the last time. Okay? So the number of times that it changes directions is going to give you the number of degrees or the power that you're most likely going to have. Okay? It's not an exact science, but it's going to give you a pretty good idea that it's at least that many. Okay? If it's going to change directions 4 times, your highest power is going to at least be 4. It's not going to be 2. Okay? It doesn't work that way. Table, okay, you have basically a spot where it says to sketch it, to where what's the left side doing, what's the right side doing, and then your limit, and then the types of solution or the type of solutions you would have, and then to evaluate it. Okay, so the main part here is, like, what do you think it's going to look like? Okay. So it's a sketch. It's nothing that is set in stone of, well, this is what it has to look like. No. Okay? What's your highest power? 4. Okay? So how many times do you think, knowing what we just talked about, how many times do you think this thing is going to change directions? Probably 4. Or at least whenever you draw your sketch, you need to at least make it change directions 4 times. Now, which way is it going? It's going to be pointing up in both directions, right? So then, if I sketch this, I'm going to look something along the lines of, it's going to look kind of like that W. Okay? So if we're just going to talk, this is going to be number 7. Okay? And then we'll talk about number 8, and then 9. So if it looks kind of like a W, now for the left and the right, which way is the left side? If we put it in words, which way is the left side going? Well, which way is the arrows pointing? Up, right? What about the right side? Up again. Okay. Now, the left, now if we write it in like notation, as x is going left, what is f of x going towards? Is it going towards positive infinity or negative infinity? Positive infinity. Okay? So it's real simple. If you write down, if you put up, then you need to have f of x going to positive infinity. So if you have down written, what does f of x need to be going to? Negative infinity. Okay? You wouldn't believe how many students cannot put 2 and 2 together. So then, same way, okay, this is just a fancy way of saying left. That's a fancy way of saying right. Okay, as x is going to positive infinity. Well, that's the right side of my graph. If I say x is going to negative infinity, well, that's the left side of my graph. So then, the right side is going to match up right here. So, which way is the right side going? Is it going to positive infinity or negative infinity? Positive infinity. So I'm just going to write it as f of x, the arrow to positive infinity. Now, it's to the 4th power. So what type of graph is it? Quartic, right? Now, whenever it says to evaluate, all that means is just plug and chug. I'm going to plug in 3 to x to the 4th plus x squared minus 3. Okay? Basically, I'm going to plug in, I'm going to do positive 3 and negative 2. So, if I would do positive 3, I would just have 3 to the 4th plus 3 squared minus 3. So 81 plus 9 minus 3, and then I would get my value. I would do the same thing again for negative 2. I would have 2 answers here. Okay, is all that I'm going to do. Okay, now, what about on 8? First off, is 8 in standard form? No? So what do I have to do? Switch it, right? So if I have f of x equals negative x to the 3rd plus 4. So how's it going to look? Okay? It's a negative. It's to the 3rd power. How many different times is it going to change directions? 3 times. Okay? What side's going to be negative? The left or the right side? The right side. Okay? So the right side has to be going this direction. So what does that mean about the left side? It has to be going up. So if I just draw it something like this. You may have something different than the person next to you. That's okay. Hey, it's a sketch. So then we just look at our picture. Okay, hopefully that the picture's right. What's the left side doing? Is the left side going up or down? It's going up. What's the right side doing? Going down. So how are we going to write that in basically this fancy notation? What does it mean? Remember that left is here and right is here. So how are we going to write it as going up? F of x is going to where? Positive infinity. Okay, so f of x is going to positive infinity. What about the right side? What's the right side doing? It's going to negative infinity. What type of solutions, what type of graph is this? Cubic. Okay, and then for the last spot, we would just plug in our value. Okay. Now, last thing. So if it says to sketch a graph of a polynomial function f with these characteristics. So it has to be decreasing when x is less than negative 1.5 and when x is greater than 2.5. So basically that tells me where my turnaround points are. Okay, so if I would actually graph this, okay, and I would have, so if I'm just doing the first one here, I have 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, and 5. So what is it telling me? It's how many times does it change directions? Let's look at it that way. It's decreasing 2 places and it's increasing 1 place. So how many different turnarounds do I have? Or how many different, or what power am I going to be to? 3, right? I have 2 that it's decreasing and 1 that it's increasing. So then it just becomes really as simple as figuring out where those values are. Where's 2.5? Well, it's somewhere about here. Where is negative 1.5? Well, it's between 1 and 2. Okay? It doesn't really matter. It doesn't have to go through those points. It just means that somewhere down here, it has to be going like this direction, and then somewhere up here, it's got to go like this. Okay? Now, one thing I would tell you, make sure that whenever you draw this, okay, that if you have something, that it goes to where, I mean, it's going to be fairly, I didn't do a very good job there. Okay? That my turnaround point has to be at those spots or pretty darn close. Okay? Somewhere about where that 1.5 is, or 2.5, and where that negative 1.5 is. Okay? It's going to give you your intervals. How many times do we have a turnaround here? Okay? Y is going up, so it's written a little bit different. So y is greater than 0, so it's somewhere up top. Okay? When x is between negative 3, or excuse me, when x is less than negative 3, you've got to kind of piece it together as far as what you have. Okay? What does it mean to be greater than 1? Or greater than 0? Where's it going to be at? Up here, right? In this area somewhere. What if it's less than 0? Where's it going to be at? Down here. Okay? You've got to kind of read it and piece it together to figure out, okay, how many different times is, so like in this case, it's below 0. So that means it's down here in really 2 different areas. whenever x is between -3 and +1, and whenever x is greater than 4. Okay, so you kind of have to pay attention to where are your intervals, how many intervals do I have, so on and so forth.